Hey guys, so let's work a little more on partial fractions and let's work on some more examples from it. The varied example on partial fractions. So let me take the first question for the day. In this case, I'm taking the integral of 3x minus 2 and I am taking the case where I have one factor is x plus 1 square and the other is x plus 3 in the denominator. So this will be the case where you will have A, B, and C. So clearly, as I mentioned in the general case in the previous video, so this I should be writing it as A upon x plus 1 plus B upon x plus 1 square plus C upon x plus 3. So here when you will take the LCM, what's going to happen? So you will have 3x minus 2 is equal to x plus 1 into x plus 3 times A plus just x plus 3 times B plus x plus 1 square times C. That's what will happen. So when you will open it up, you will have x square plus 4x plus 3 here, A plus x plus 3b plus x square plus 2x plus 1 times c is equal to 3x minus 2. So comparing the coefficients of x square, if you compare the coefficients of x square, it's 0 on the left hand side and on the right hand side you have a plus you have c. Comparing the coefficients of x, you have 3 out here and you have 4a plus b plus 2c. Comparing the constant, you have minus 2 on the left side and here you have 3a plus 3b plus c, right? Now we will be solving this. What you can do is you can take A is equal to minus C or C equals to minus A, whichever way. And keep substituting. So this implies that 3 is equal to 4A plus B minus 2A. And this would become minus 2 is equal to 3A plus 3B minus A. So now you have everything in terms of, you have two equations in A and B, right? So you can just solve easily. So solving for A and B from the last two equations, what will you get? So 2A plus B is equal to 3 and 2A plus 3B is equal to minus 2. Subtracting, what I'm going to get? I'm going to get that minus 2B is equal to minus plus is equal to 5. So that implies B is equal to minus 5 by 2. Clearly, B is equal to minus 5 by 2. If B is equal to minus 5 by 2, your A will turn out to be 3 minus 2A will be 3 minus 5 by 2, that is that is 11 by 2, and that means A will be 11 by 4. If A is 11 by 4, then C is minus 11 by 4, right? So your integral will look like the integral 3x minus 2 dx whole upon x plus 1 square into x plus 3 will look like 11 by 4 integral 1 upon x plus 1 dx minus 5 by 2 integral dx upon x plus 1 whole square minus minus 11 by 4 integral dx upon x plus 3, right? So integrating this is very simple. This will give you I is equal to, if we call this integral I, the usual notation, it is equal to 11 upon 4 log mod x minus x plus 1, sorry, plus some constant, which we can just add up in the end, log mod x plus 1 whole square. Since there was square, so okay, now you don't have log here. It's going to be 5 by 2 minus 5 by 2 it's going to be 5 by 2 minus 5 by 2 as it is, and 1 upon x plus 1 upon x plus 1 plus, no, minus 11 by 4 log x plus 3 plus some constant c, right? And what you can do is, since you have 11 by 4 is common here, and you have log, so you can, add, there's a minus sign, so you can just write it down, combine and write down that you have mod x plus 1 upon x plus 3, right? And minus 5 upon 2 into x plus 1 plus c. So that would be the final answer. Let's take some more cases now. Let's take another question. So question 2. Let's take a case where in the numerator also you have a square. So let's take a case where you have integral, you have to integrate x square upon x square plus 1 into x square plus 4 dx. So instead of whole square, we have x squares here. Now, again, since you have factors in the denominator, we can, well, first of all, to simplify, what we can do is we can take x square as y, and 2x dx is equal to dy. 2x dx is equal to dy. And this integral will become y upon y plus 1, y plus 4. The fraction would become this. And let's just, first of all, decompose it as partial fractions. A upon y plus 1 plus b upon y plus 4, right? A upon y plus 1 plus b upon y plus 4. So y is equal to y plus 4 times a plus y plus 1 times b. Okay, that's the LCM. So comparing the coefficients of, if we compare the coefficient of y, you have a plus b, constant is 0 here, and you have 4a plus b. Now adding it up or subtracting, we'll get that subtracting, you will get that 1 is equal to minus 3a. That implies a is equal to minus 1 by 3. The moment you get a is equal to minus 1 by 3, that means b is equal to 1 plus 1 by 3. It's going to be 4 by 3. So hence your integral turns into, say, if I call it I, the integral would be integral x square upon x square plus 1, x square plus 4 would be equal to dx would be equal to actually I can directly now just integrate using x only. I don't require y. So I can just write it down as minus 1 by 3 dx upon x square plus 1 plus 4 by 3 dx upon x square plus 4. So it's going to be minus 1 by 3 tan inverse x plus 4 by 3 tan inverse 4 by 3 into 1 by 2, because this time it's x square plus a square, a is 2. So 1 upon a tan inverse x by a. So x by a is half. So upon x upon, a is 2, sorry. So a is 2, so x upon 2 plus c. So it's going to be minus 1 upon 3 tan inverse x plus 2 by 3 tan inverse x by 2 plus c. Okay. Let me take another question. And here let's take a little difficult. Let's take a trigonometric function out here. So let's take a function wherein I have to integrate. It's a question. I is equal to integral 3 sine phi minus 2 whole thing upon 5 minus cos square phi minus 4 sine phi, and here cos phi also. Okay, cos phi d phi. Okay. Now let's take let's do something here to simplify. Let's take y as sine phi, then dy will be equal to cos phi d phi. Dy will be equal to cos phi d phi. So your integral I would turn into 3y minus 2 upon, and because cos phi d phi is dy, so just dy here, upon 5 minus 1 minus y square minus 4y. Or in other words, it will become 3y minus 2 whole thing upon 4 plus y square minus 4y, or in other words, that would actually be integral 3y minus 2 dy upon y minus 2 whole square, which now with using partial fractions, I can do something out here, which can be written as now 3y minus 2 upon y minus 2 whole square could be written as a upon y minus 2 plus b upon y minus 2 whole square. And let's find out a and b. So 3y minus 2 is equal to y minus 2 times a plus b. So comparing the coefficients, I would get that 3 is equal to a and minus 2 is equal to minus 2a plus b. So that implies b is equal to 4. B is equal to 4, right? So we can write down the integral that we have. The integral that we have could be written as, the integral that we have can be written as equal to 3 upon, it is equal to 3 upon integral dy y minus 2 plus 4 times dy upon y minus 2 square, right? In other words, this will be equal to 3 log mod y minus 2, 3 log mod y minus 2 plus 4 times minus 1 upon y minus 2 plus c, right? So this will give you 3 log mod y minus 2 minus 4 upon y minus 2 plus c. Now in place of y, you can substitute back. So this is 3 log mod sine phi minus 2 minus 4 upon sine phi minus 2 plus c. That's going to be the correct answer. Now here you can also do one thing. You can also actually just add up something here. And that something is, we know that, sine theta is always lesser than 1, right? Sine theta is always less than or equal to 1, right? So therefore, sine phi minus 2, sine phi minus 2 will actually be strictly less than 0, right? And 2 minus sine phi will be strictly greater than 0. So therefore, the integral will turn out to be 3 times log, in place of mod, you can directly actually just write down 2 minus sine phi. You can actually just write down 2 minus sine phi, which will be the positive part that will always come out. 4 upon sine phi minus 2 plus c. Now I'll give you another example for partial fractions, which is as following. So another question wherein I'm taking a polynomial in the numerator. So let's take x squared plus x plus 1 upon x plus 2 x squared plus 1 dx. Now we know that we can write it down as, remember, I've given you the generalized form, what you can break it up as. So this kind of fraction can be broken up as a upon x plus 2 plus bx plus c upon Now let's find out what will be our a and b. So let's take the LCM first. So x squared plus x plus 1 is equal to x squared plus 1 times a plus x plus 2 times bx plus c, right? So let's compare the coefficients. Comparing the coefficients of x square, you will get a plus b is equal to 1. Then for x, you will get 2b plus c is equal to 1. And then for constant, you will get a plus 2c is equal to 1. So you have this information. With this, you can easily solve. So you have that b is equal to 1 minus a, b is equal to 1 minus a, c is equal to 1 minus 2b. So let's just put everything together here. A plus 2 minus 4b is equal to 1. So a plus 2 minus 4, 1 minus a is equal to 1. That means 5a minus 2 is equal to 1. That implies a is equal to 2 by 5. The moment you have a is equal to 2 by 5, a is equal to 2 by 5. So you can find out b is 1 minus a. So it's going to be 3 by 5. And c is 1 minus 4 by 5. That is 1 by 5, right? Oh, a little mess up here. It's going to be a is 3 by 5. And hence b will be 2 by 5. Well, I've done it correct for c. C is 1 by 5. And now let's just substitute. So let's just substitute. Substituting the partial fractions, we would get the following result. Your integral I is equal to 3 by 5 integral dx upon x plus 2 plus 2 by 5x plus 1 by 5 upon x square plus 1. So dx. Hence, this will give you, this is simple 3 by 5 log mod x plus 2 plus, here what you will have to do is you'll have to break it up. You can break it up and this will give you 2 by 5 integral x dx upon x square plus 1 plus 1 by 5 integral dx upon x square plus 1. So in this case, you will have to take x square plus 1 as, say, some t. Take this as some t and 2x dx becomes dt. So this was simple log already integrated. Now here the integral will give you 2 by 5 log, not 2 by 5, 2x goes off. So 1 by 5 log mod x square plus 1. After substituting, guys, you'll have to substitute x square plus 1 as t, hence 2x dx equals to dt. Plus 1 by 5. Now you have x square plus 1, which is tan inverse. This will give you tan inverse x. So tan inverse x plus some constant c. So I've done all the cases more or less for partial fractions example of each and every general case that I gave to you. So this is how you use partial fractions in different cases.